So you have this as the formula for the lateral areas of the pyramid. Okay. So let us try solving one problem here. We are going to find the total area of a regular pyramid, which is 16 centimeter high, with a rhombus base. Okay. The base is a rhombus. The side is 24 centimeter, and it has a 10 centimeter in one diagonal. Now, can you view what I am writing on my figure, on my screen? Not yet. Let me end my presentation. Okay. Can you view my camera?
Yes, po.
So according to the problem, we are going to find the total area of a regular pyramid. Let's go back to the problem. According to the problem, we are going to find the total area of a regular pyramid with rhombus as a side, 24 centimeter, and 10 centimeter in one diagonal. So what do you mean by rhombus? How do you draw a rhombus? Anyone who knows what a rhombus is?
Para po siyang dalawang parallel lines. Dalawang set ng parallel lines.
Okay. So that is also similar to, almost similar to a what? Almost similar to a square. Okay. So rhombus is the same or almost similar to a parallelogram. The only difference is that all sides are equal. So tama si Charles doon. Para silang sa parallel sides. But the only difference is that pwede nyo nang i-off yung inyong camera. So you can view my presentation on a larger scale. Okay, sige, you can off your camera. Carl, Princess, can you off your camera? So we can have a larger view of the figure. Okay, there you go. Tama si Charles doon kanina. So you have here parallel lines. Okay, the only difference is that in parallelogram, only two pair of sides are equal. But in the case of rhombus, all sides are equal. Okay, so if you are going to draw a pyramid, that means we have a vertex. And the vertex is the point where all the lateral faces are meeting. So that is the common point. So if you are going to draw a pyramid, kindly bear with my figure here with my drawing. I am using a freehand drawing here. So this is the pyramid that we are talking about. And what we have here, the base is a rhombus. So let me just, so you can have a better view of this. Okay. So the base is a rhombus. And according to the problem, the regular pyramid has a height of 16 centimeter. So the height of the pyramid, if we are going to draw the height of the pyramid, that is from the vertex down to the base. I am not drawing not to scale. I am drawing not to scale, huh? So this is what you call as the height. That is 16 centimeter according to the problem. And one of the sides of the base is 24 centimeter. So that means this is 24 centimeter. And because the base is a rhombus, okay, we have a rhombus base. Later on, we are going to draw the base. Let's isolate the base. Can you still see what I am writing on my board here?
Yes po, ma'am.
Okay, so the base is rhombus. And one of the sides, diagonal, I mean, is 10. So if we draw the diagonals, these are the two diagonals of the rhombus. And according to the problem, one of the diagonals is 10. So let us say this is 5 plus 5. Okay, so that is the base. And this one is our three-dimensional figure photo for the pyramid. So if you are going to notice, if this is 24 centimeter, this side is what? This is half of the 24 centimeter. So that means this is 12 centimeter. So this is 12 plus 12, that is 24 centimeter. So if you are going to take a look at this figure, okay, we can isolate this figure. Take note of this. We can isolate this figure and you would notice we can create a right triangle here. So again, we are going to go back to our basic technique. What we have to do is to look for a right triangle. Okay? Yun yung tinuro ko sa inyong technique data, di ba? So you have to look for a right triangle always. You would notice that if we isolate that particular figure, we can create a right triangle. Okay. So this is our right triangle. And you would notice, what is this height? This is 16. What is this side? This is 12. Okay. So this is 16 centimeter. This is 12 centimeter. And this one, how do you call this one? What's the value of this? If this is 16, this is 12, how do you call this one?
Slant height.
Okay, very good. So that is the slant height. That's the difference between the altitude and the slant height. This is the slant height, while this one is the altitude. So if you are given a problem and you're given the altitude is taken from the vertex down to the base in perpendicular distance. But the slant height is a different thing. So the slant height is taken from the vertex down to the base, but take note, it is not perpendicular with the base. Okay, in this particular case. Okay, so you have the slant height. It has a certain degree with degree angle with the base. Okay. So the question here is, since we are given all these figures and all this data, what we are going to determine is the what? The question is total area. So we are going to find, can you still view what I am writing?
Yes po.
Okay. So we are going to find the total area. And remember that our formula for total area is what? Total area is equals to the lateral area of the sides of the pyramid plus the area of the base. Okay. So the same is true with what we have discussed previously. To determine the total area, that is simply equals to the lateral area plus the area of the base. So the question here now is, what is the lateral area and what is the area of the base in order for us to solve for the total area? So let us solve first for the slant height. Okay. Let us solve first for the slant height. Let's say this is point P. Let's this say this is point O. And let's say this is point A. Okay. If that is the case, then this triangle POA, we can determine the slant height, which is basically the distance or the line segment AP. Okay. So line segment AP is this slant height. So how do we determine the slant height? What will be the formula for the slant height?
Pythagorean theorem po.
Okay, very good. So we are going to make use of the Pythagorean theorem. So how do we determine the slant height using the Pythagorean theorem? How do you determine the slant height using the Pythagorean theorem? We have slant height squared is equals to 16 squared plus 12 squared. Can you still follow?
Yes po.
So the slant height is equals to the square root of 16 squared plus 12 squared. Will you please calculate for the slant height?
20 po.
We have 20 centimeter. Okay. So next, what do you think will be our first move? A second move. So after determining the slant height, can we now determine the perimeter of the base? Can we now determine the perimeter of the base? How do we determine the perimeter of the base? You've got 1, 2, 3, 4. How many? How many sides do we have for the perimeter of the base? We have how many sides? Anyone? How many sides do we have for the base?
4 po.
Apat. Okay, so in order for us to determine the perimeter, we're just going to add all the sides of the base. So what will be the perimeter of the base? How many sides do we have? 4. Multiply it by how much? Multiply it by how many?
24 po.
Very good. 24. 24 centimeters. So the perimeter of the base is equals to 90, okay, 96 centimeter. According to theorem number 1, the lateral area is equals to what? The lateral area is equals to
Sum of the areas of the lateral faces po.
lateral area is equals to 1/2 times the product of the perimeter of the base multiplied by the slant height. That is according to our theorem that we discussed. The lateral area is equals to 1/2 times perimeter of the base times slant height. So that means lateral area is equals to 1/2. Perimeter of the base is 96. The slant height is 20. So what's the lateral area? Sorry. What is the lateral area? Kindly compute.
960 po.
960. The unit is?
Centimeters.
What is the unit? 900.
Centimeters squared po.
Okay. Square centimeter. So we have 960 square centimeter. That is the lateral area. But take note, the question is total area. So we have yet to determine the area of the base. So how do we determine the area of the base? Take note that we have a rhombus base. So if you are going to determine the area of the base, okay, so the area of the base is simply equals to, how do you determine the area of the base? Remember, we have x here, we have 5, 5. So that is according to the problem. One of the diagonals is 10. So we don't know this diagonal, the second diagonal. Let's say that is x, and let's say this is also x. And if you are going to notice, isolating the right triangle again. So again, the technique is to find a right triangle. Okay, if you are going to isolate this right triangle, this is 5. This one is x. What about this value? What is the value of the third side? What is the value of this third side?
24 po.
Okay, so that is 24 centimeter. So this is 5, this is x, so this is 24 centimeter. So how do you determine the area of the base? We need to compute for x first, so we can determine the area of the base. Here. Okay. So how do you determine this value of x? How do you determine the value of x? Again, by? How do you determine the value of x? Using this right triangle? Again, by Pythagorean.
Pythagorean theorem.
Okay, Pythagorean theorem. 24 squared is equals to 5 squared plus x squared. And if you would like to determine the value of x, that is simply equals to the square root of 24 squared minus 5 squared. So that we will have the value for x is equals to, kindly calculate if you have the same value as I have computed, 23.473 centimeter. And the other diagonal will be 2x. The other diagonal is 2x, and that is equals to 46.95 centimeter, or if you are going to round it off, that is roughly equivalent to 47 centimeter. So now, if you are going to determine the area of the rhombus base, that is simply equals to 1/2 times d sub 1 times d sub 2. So that is the formula for a rhombus. All you have to do is to determine the diagonals. The area of the rhombus is 1/2 d sub 1 times d sub 2. So that is why you have 1/2 for the area of the base, that is equivalent to 1/2. D sub 1 is 10. D sub 2 is 47. And that is roughly equivalent to ilan?
235 po.
235 square centimeter. And that means if you would like to determine the total area, you just add up lateral area plus the area of the base. So the total area is equals to, lateral area is 960 square centimeter plus 235 square centimeter. And that would mean the total area is equals to, you please calculate for this one.
1,195 centimeters.
1,000. Okay, so 1,195 square centimeter. And this will be our answer. That is the total area. Any question? Later on, we are going to discuss some more problem, in which we are going to find the the basis and the area by simply making use of the triangle. Okay? So all you have to do is to determine first the area of the lateral faces. So you would notice if this is the lateral face, once you have the slant height, okay, actually the formula for this lateral area is taken from the area of the slant height, and then you multiply it by the number of sides. Okay? Sige, how do we do that? Do you have any question? Meron kayong question? Okay. Let me just explain how we arrive with the formula of the theorem for the lateral area. Take note, the lateral area is equals to 1/2 times perimeter of the base times the slant height, diba? Okay? So that was a given formula already. So you can derive, kung medyo nakalimutan nyo, pwede naman kayong mag-proceed into determination of the lateral area by using the basic geometry. Okay? If you are going to take a look at this, diba? This is a triangle. So let's say this is point B. This is point C. That is point O. If you are going to isolate the triangle, okay, this is point P, this is point B, and this is point C. And take note, this is point A. The distance from A to P is what you call as the slant height. From A to P is your slant height. And according to our computation, for the slant height, the value of the slant height is 20 centimeter. Okay, you have the value for the slant height is 20 centimeter. While the value for this line segment, from line segment BC, which is equals to this one, which is equals also to 24 centimeter, diba? If this is 24, because we have a rhombus here, this is also 24, this is also 24, and this is also 24. Okay? So you have the line segment BC, this is 24 centimeter. Okay? And if you are going to take a look at this, you have the formula for the area of triangle. So that means if you are looking for the area of triangle PBC, that is simply equals to 1/2. Area is 1/2 base times height. So our height here is the slant height. So you have 1/2, you have 24, and then slant height is 20. Will you please calculate for this?
240 po.
240 square centimeter. So you can use that as our, is that 240? Okay, so 1/2 times 24 times 20. So you have 240. You can use that to determine the lateral area. Okay, the total lateral area is simply, how many sides do we have? How many lateral faces do we have?
4.
We
4.
have 4, di ba? We have 4. So you multiply 4 by the area of one lateral face, which is 240 square centimeter. And that is roughly, that is also the same as the value that we get. That is also the same as 960. That is the same as 960. Okay? So that's why you have here the lateral area 960. Can you figure it out?
Yes po, ma'am.
Okay. So the same, that's basically the same principle of the theorem that was presented. Okay. So all you have to do is to get the area, of one lateral face, then you multiply it by the number of faces. So you would have the total lateral area for the pyramid. Any question? Any question?